This video is for your notes on equations and models. It covers pages 107 through 112 in your notebook. You'll need one pencil and 4 colors to complete these notes. You'll not get credit if you don't do the highlight. A mathematical sentence with variables, numbers, and/or operations that represents a situation without any statement of equality or inequality. So without equality means that it's not going to have an equal sign. And without inequality means it's not going to have an inequality symbol, like the less than, greater than, the greater than or equal to, or the less than or equal to symbol. So it doesn't have any of those symbols. This is called an expression, so 2x plus 3 or 7x squared minus 5. A mathematical sentence that compares two equivalent expressions is going to use the symbol, the equal sign. Now it's saying that 2x plus 3 is equal to 7x squared minus 5. So you have two expressions that are equal. This is called an equation. A mathematical sentence that compares two unequal expressions might use the symbols less than or equal to, greater than, or greater than equal to. So this is saying that the expression 2x plus 3 is actually greater than 7x squared minus 5. They're not equal. One is bigger than the other. And this is called an inequality. A symbol denoting a mathematical action. So the minus sign, the plus sign, they are mathematical actions. And those symbols are called operations or operators. Parts of an expression separated by plus or minus signs. So you kind of separate at the plus and minus signs. So if you draw lines where the plus and minus signs are, the three sections that it got separated into are terms. So terms make up expressions. A symbol that's used in place of an unknown number or value, and the most common symbols used are letters. So we have the x and the y. Those are variables. The number in a term that has no variables. So over here, if we separate this, the 4x squared has a variable, 2x has a variable, but 3 doesn't. It's constantly alone. So it's called a constant. The numerical factor, so number or multiplication, in a term containing variables. This number that's being multiplied by a variable, it's cooperating with the variable, so it's a coefficient. With this x squared, if we don't see a number, it's technically saying that 1 times x squared is just x squared, so the coefficient here is 1, and the coefficient next to the x, we have 2x, so the coefficient is. We're going to go through, and every single time you see an equal sign, then we are going to have an equation. So each of those two that had equal signs is an equation, and this has an inequality symbol, so this is an inequality. Every other math sentence that doesn't have an equal sign or an inequality sign is an expression. So these don't have any equality or inequality symbols, and these are expressions. And we're going to draw the bracket to show which ones are expressions. Now, equations and inequalities are comparing two equal or unequal expressions. So each side of those number sentences are expressions as well. Now, expressions are broken up by terms. So equations and inequalities are built with expressions, and expressions are built with terms. So this is a one-term expression. And the left side of the expression, we are going to put a box around 2x. We're going to stop at the plus sign. The plus sign is separating those two terms in the left side of the expression, and there's only one term on the right side of that equation. Now this equation, we have 3x. We're going to stop at the plus sign. We have 5y. We're going to stop at the minus sign. And we have 6. So the left side of the equation, that expression has 3 terms, and the right side of the equation, that expression has 1 term. So in this expression, we're going to stop at the minus sign, and we have 5x cubed is a term, and 2x is a term. We're going to stop at the plus sign, and 5 is a term. So that expression has 3 terms that are separated by the plus or minus signs, or the operators. 7x squared is a term, and we're stopping at that plus sign, and 3 is a term. So the left side of that inequality, that expression has 2 terms, and the right side of that inequality, that expression only has 1 term. Now this expression, we're going to separate the terms with plus and minus signs, and we have 6p cubed is a term, 4g is a term, and 1 is a term. So that expression has 3 terms. Now there's 2 different types of terms. There's a term that has a variable and a term that does not have a variable. So we are going to color code variables, and we're going to go through and highlight all of the variables yellow. So x is a variable, this x is a variable, the x, the y, the x, this x, an x, but you could also have different ones, p or g, whatever letter you have will be a variable. Now, in the terms that have variables, the numbers that are multiplying by the variable is the coefficient. So in this term of 6x, the 6 is the coefficient. 2x, the 2 is the coefficient. 3x, the 3 is. The 5 is with the y, the 5 is with the x cubed, the 2 is with the x, the 7 is with the x squared, the 6 is with the p cubed, and the 4 is with the g. So inside of those boxes of terms, all of those numbers that are multiplying themselves by the variable are called our coefficients. Now the other terms are going to be constants because they're constantly alone. They're not with the variable. So 3 and 7 don't have variables, so they're constants. This 6 and this 7 do not have a variable in the box with their term. This term of 5 is a constant term. This term of 3 and this term of 5 are constant terms. We look for this last one that does not have a variable. So 3, 7, 6, 7, 5, 3, 5, 1, all of those terms are constants. Now we can also have an exponent. So every single variable technically has an exponent on it. So if you do not see an exponent, that's because we only have one of those variables. So each of these variables has an exponent of 1 unless another number is written. So this x has a variable of 1, an exponent of 1. We have an exponent of 1, of 1, of 3, of 1, and on 7x squared, the exponent is 2. On 6p cubed, the exponent is 3, and 4g, the exponent is 1. Now let's look at this last equation and kind of see how this is separated. So it's an equation because we have an equal sign. And the equal sign is what separates the equation into 2 expressions. So we have 5x squared plus 9j minus 3 is an expression, and 7 is an expression. So equal signs separate equations into expressions. Now expressions are broken down into terms, and the plus or minus signs separate those. So you have 7x squared as a term, separated by the plus sign. 9j is a term, separated by the minus sign, and we have 3. On the other side, that expression is just 7. Variables are the letters, so in the 5x squared and 9j, we have the letters x and j, and in the 5x squared, our number is 5, in the 9j, our number is 9. So the coefficients that are with those variables, the numbers that are being multiplied by those variables, are our coefficients. So you could break down that one term into variable terms, but we could also break the other terms down into constants. So our constants are 3 and 7, our operators are plus and minus, and our exponents are 2 and 1. There are 4 basic operations: addition, subtraction, multiplication, and division, and each one is matched up with another one that undoes it. So if I go 4 plus 7 and I get 11, I add 7 to get 11, and then I subtract 7 and I'm back at 4. So subtraction undoes addition. If I have 12 and I subtract 8, I get 4. And if I add 8 back, I'm back to 12. So addition undoes subtraction. If I have 6 times 3 to get 18 and I divide by 3, I get back to 6. If I divide by 56 by 7 and then multiply 7 back, I get back to 56. So multiplication and division are inverses of each other. They undo each other. So if I add 6 and then subtract 6, I'm going to end up with the same number. So if I add 1, I want to subtract 1 to get back to that number. If I add 5, the inverse is going to be subtracting 5. If I add 15, the inverse is going to be subtracting 15. So if what I'm doing is adding and I want to figure out what my original number was, I just need to subtract. So if I subtract 9 and then add 9, I get back to the original number. So the inverse of subtracting 3 would be adding 3. The inverse of subtracting 5 would be adding 5. And the inverse of subtracting 6 would be to add 6. So if I don't know what my original number is, but I know that I added 6 and then subtracted 6 to get 7, then I can figure out what my original number is. Now, if we look at this next one, we see that we have a few different signs for multiplication and a few different signs for division. And we also need to remember that fraction means division. So if I have 3, I multiply by 5, and I divide by 5, I'm going to end up with 3. 7 times 4 is undone by dividing by 4. Times 9 is undone by dividing by 9. Timesing by 8 is undone by dividing by 8. And if I divide by 6 and then I multiply by 6, I'm going to end up getting back to my original number. So if I divide by 5, I can undo that action by multiplying by 5. If I divide something by 8, I can undo that action by multiplying by 8. And if I divide by 3, I can undo that action by multiplying by 3 to get back to that original number. Here we have an equation model. So this triangle means x, and I have 4 1s. So I have x and 4, and is going to be a plus sign. On the other side, I have 1, 2, 3, 4, 8, 12. I have 12, and it's showing me that I have 1x and I have 4 1s will equal 12 1s. So that is my actual equation that's being represented. So I want to solve for x. I want to figure out what x is, which means I want to get rid of that 4. So if I want to get rid of that 4, so x plus 4, the inverse operation is going to be to take away 4. So I'm going to take away 4 from this side to get x alone, and I would need to take away 4 from the other side. So if I take away 4 from the left, I get x, and I take away 4 from the right, and I get 8 left over. So I see that that x is equal to 8. But I want to double check that. So I have something plus 4 should equal 12, and I want to double check that. So I think that x should be 8. So x or something plus 4 is equal to 12, and I'm going to try 8 in there. Well, 8 plus 4 is 12, and that's what I wanted, so I know that answer is correct. So I know that x is equal to 8. Make sure you don't put 12 as the answer. 8 is what x is equal to. Now here I have 2 x's. So I have an x here and an x here. If I have 2 x's, I have 2 groups of them. I'm going to write 2x. And I have 1, 2, 3, 4, 5, 6. And we see here that 2 x's are equal to 6 1s. So 2 groups of x, that actually means multiplication. So when you see a number next to a variable, that means multiplication. So what undoes that times 2? Well, dividing that into 2 groups. So if I divide that into 2 groups, I have x in each group. And if I divide the right side into 2 groups, then I'm going to have 3 in each group. So my final answer is x equals 3. But I want to double check that the x equals 3 works when I put it back into my equation. So I see 2 times x, whatever I think x is, should equal 6 if I picked the right answer, if I solved it correctly. So I'm going to put 3 in for x, and 2 times 3 is 6, and 6 is what I wanted, so I know that x does actually equal 3. It checks out. Make sure that 3 is your answer and you don't accidentally put 6 as your answer. That's a common mistake after checking your problem. So the answers are here what x is equal to, not what you get at the bottom of the problem. Now this key, we have an x plus, and we have 1, 2, 3, 4, 5 groups of 2, because in our key it's saying that these circles now equal 2. And I have 2, 3, 4, 5, 6, 7, 8. I have 8 groups of 2 on the other side. So I have x and I have 10, and that equals 16. So x plus 10 equals 16 is what this equation is represented as. So I want to solve for x, which means I want to get rid of those 10 circles that are on the same side as x. So to get rid of them, I am going to take them away. So I'm going to take 10 away from both sides. And if I take 10 away from the left side, I'm left with x. So minus, I'm going to take away 2, 4, 6, 8, 10, and I'm left with x on this side. And if I take away 2, 4, 6, 8, 10, I'm left with 2, 4, 6. So 16 minus 10 is equal to 6. And x equals 6 should be my final answer. However, I want to double check that. So we always want to put what we think our variable is equal to back into the equation to see if it makes sense. So x plus 10 should equal 16, and we think our answer should be 6. So 6 plus 10 is 16, and we know that our answer is correct. So now we're going to write our answer in the answer column. Over here we have 1, 2, 3 groups of x, so 3 x's, and we have 1, 2, 3, 4, we have 12 groups of 2. So 12 groups of 2. So 3x equals 12 times 2 is 24. So our equation is 3x equals 24. So we want to solve for x, and this 3x means 3 times x. So I'm going to divide 3x's into 3 groups. So if I divide both sides by 3, or divide it into 3 groups, we get x on the left, and 24 divided into 3 groups, we're going to get 8. So we think that x is equal to 8, and we're going to double check that. So 3 times whatever x is should equal 24. So 3 times 8, that looks like 38 right now, but it's actually 3 times 8 should be 24. Make sure we put that multiplication in there. And 3 times 8 is 24, which is what we wanted. So we see that x equals 8. And if you divide it into 3 groups on the left, we see that each one has x, and each one on the right has 8. Now I want to get rid of this times 4, because I want to know what x is equal to. So what are we doing in the x? We're multiplying by 4. The inverse is dividing by 4. So we want to figure out what x is. I want to isolate x. I want to get rid of everything that's on the side of x. So I'm going to divide both sides by 4, and 4 divided by 4 is equal to 1, and 1 times x is x, and 32 divided by 4 is 8. So I'm going to try 8 in there, and 4 times 8 is 32, and 32 is what I wanted x to equal. So 32 is what I wanted x to equal, so I checked my problem, and that means that my result is correct. In this next problem, I want to see what h equals. I don't want to know what h plus 7 equals. I want to find out what h equals. So I want to get rid of that plus 7. So what's being done is we are adding 7 to h. So to undo that to get back to h, we are going to subtract 7. And because it's an equation, we need to do the same thing to both sides, because equations are balanced. 15 minus 7 is 8. And 7 minus 7 is 0, and h plus 0 is just h. So now we see that h equals 8. So we're going to put 8 back in the equation that we wrote, and 8 plus 7 is 15, and 15 equals 15. So now we see that it checks out, and h does actually equal 8. Now I want to know what m is equal to. I don't want to know what m divided by 4 is equal to. So I want to undo this dividing by 4. So we have m and we're dividing it by 4, so we need to multiply it by 4 to undo that division. So we're going to multiply both sides by 4, and 4 over 4 is 1, and 1 times m is m, and 12 times 4 is 48. So now we put a 48 back in there, and 48 divided into 4 groups is 12, and that's what it should be. So it checks out, and 48, or that result, is our final answer. And we know it's correct. Now, I want to know what k is equal to. I don't want to know what k minus 9 is equal to. So to undo that subtracting by 9, I am going to add 9. So I'm going to add 9 to both sides. And 9 minus 9 is 0, and 0 plus k is just k. And 9 plus 7 is 16. So I go through and I check my answer, and 16 minus 9 is 7, and that's what we wanted. So we know our result of 16 is correct. Now I want to know what j is equal to. I don't want to know what 6 plus j is equal to. So if I want to get rid of that 6, so right now we are adding 6 to j, and I'm going to take away 6. So I'm going to take away 6 from both sides because equations need to stay balanced. Now 6 minus 6 is 0, and 0 plus j is j, and 12 minus 6 is 6. So I put that back in, and 6 plus 6 is 12, which is what we wanted it to check out to. And we know our result of 6 is what j is equal to. Now here, 4i equals 24. And when we have a number next to our variable, that means multiplication because that coefficient means that it's being multiplied by I. So right now we're multiplying I by 4, and to undo that we need to divide both sides by 4. So 4 divided by 4 is 1, and 1 times I is I, and 24 divided by 4 is 6. So I think that I is equal to 6. And 4 times 6 is 24, and that's what we wanted I to equal. So it checks out, and we know that our answer is actually 6. Here we have x is being divided by 3. I don't want to know what x divided into 3 groups is. I want to know what the full x is equal to. So right now we are dividing by 3. So to undo that, we need to multiply by 3. So we're going to multiply both sides by 3, and those inverse operations cancel out to get x, and 6 times 3 is equal to 18. So we're going to put that back in there, and 18 divided by 3 is equal to 6, and we see that that answer checks out, so our result of 18 is correct. Now, I don't want to know what y minus 8 is, or 8 less than y is. I want to know what y equals. So here we see that we're subtracting 8, and I want to add 8 to both sides. So I would be adding 8 to both sides, and taking away 8, then adding 8, cancels each other out, and we get 0, and y plus 0 is just y. And on the right side, 9 plus 8 is 17, but 17 minus 8 is 9, so we see that 9 checks out, and 17 is our final answer. Make sure you don't put 9 as your answer, and you're putting 17 as your answer, because y is equal to 17. We want to know what x is equal to. So basically, we want to know 4 times what is going to give me 20. Now, I don't want you to just figure out what goes in there because we're going to start having some more difficult numbers. We need to understand that the opposite of multiplying by 4 is dividing by 4, and multiplying by 4 then dividing by 4 is going to cancel out to give you x, and 20 divided by 4 is 5. So here I think that my final answer is 5, but I want to double check that by putting it into the problem. And I know that 4 times 5 does equal 20, so x equals 5 would be my final answer. Now we want to do it show our work algebraically because we're going to start getting some more difficult problems than what you're seeing on Ms. Szymanski's notes. So I want to know 2 plus what is equal to 4. And you can probably do that in your head, but make sure we're showing this algebraically. The opposite of adding 2 is going to be subtracting 2. So I need to show that on both sides. 2 minus 2 is 0, and 0 plus x is just x. And 4 minus 2 is 2. So I think that x equals 2, and I'm going to put 2 in there for x, and 2 plus 2 does equal 4. So now I can write x equals 2 as my final answer. Now I want to know what number minus 9 is going to give me 11. So if I add 9 to both sides, 9 minus 9 cancels out to be 0, and 0 plus x is just x. And 11 plus 9 is equal to 20. So I want to know what number minus 9 equals 11. And I got that x is equal to 20. So I want to try 20 into my number sentence. And 20 minus 9 does equal 11. So now I'm confident that x equals 20 is the correct answer. So you can always go back and check your answers. You should know if your answer is correct or incorrect before writing it down. This number 4, I want to know what number minus 4 is going to give me 7. So the opposite of subtracting 4 would be to add 4. So I'm going to add 4 to both sides, and x equals 7 plus 4, or 11. So I think that 11 is my final answer, and I'm going to replace x with 11 because that's what I think its hidden value is. And 11 minus 4 does equal 7, so now I'm confident that x equals 11 is my final answer. For number 5, we want to know 5 times what number is equal to 25. So when we have a number next to the variable, that actually means 5 times the variable, or 5 groups of the variable. So the opposite of multiplying by 5 is going to be dividing by 5, and we're going to divide both sides by 5. 5 divided by 5 cancels out to be 1, and 1 times x is just x. And 25 divided by 5 is 5. So we're going to check that out, and we put 5 in for x, and we see that 5 times 5 does equal 25. So now I'm confident that my final answer of x equals 5 is correct. For number 6, we want to know what number divided by 11 is going to give me an answer of 2. So what number divided by 11 will give me 2? Well, the opposite of dividing by 11 would be to multiply by 11. So if I multiply both sides by 11, those inverse operations cancel out to give me x on the left side, and 2 times 11 is 22. So I think that x is equal to 22. So in that equation, I'm going to replace x with 22. 22 divided by 11 does equal 2. So I'm confident now that x is equal to 22 is my final correct answer. Now on this problem, I want to know that 3 times what will equal 6. I want to know what that is that I'm multiplying by 3 to get 6. So I can divide both sides by 3, and 3 divided by 3 is equal to 1, so that cancels out to be x. And I'm trying to see that 3 times what equals 6. So that 3 divided by 3 cancels out to be 1, and 1 times x is just x. And 6 divided by 3 is 2. So I think that x is equal to 2, and I'm going to put a 2 in there, replace for x. And 3 times 2 is 6, so I'm confident that x does, in fact, equal 2. For question number 8, I want to know what number plus 6 is going to give me 11. So that number plus 6 should equal 11. Now I want to know what that number is. So if I want to get rid of this plus 6 so I see what x is equal to, I'm going to subtract 6. So the opposite of adding 6 is subtracting 6. And 6 minus 6 is 0, and 0 plus x is x. And 11 minus 6 is 5. So I think that my answer is 5. So I plug that in, and 5 plus 6 does equal 11. So now we know that x equals 5. And we also know that Ms. Szymanski likes the number 5 with all of these answers. 10 plus x is equal to 16. So we want to know 10 plus what equals 16. I want to figure out that actual number. So if I want to get rid of that 10, I'm going to take it away from both sides. So 10 minus 10 is 0, and 0 plus x is x, and 16 minus 10 is 6, so I think that x equals 6, and 10 plus 6 does equal 16, so I know my answer of x equals 6 is indeed correct. So x equals 6. I want to know that what times 5 would give me 15. So that x times 5, in parentheses means multiplication, would give me 15. So I want to get x alone, so I'm going to divide both sides by 5, and 5 divided by 5 is 1, and 1 times x is just x. And 15 divided by 5 is 3. So I think that my answer is 3. I think that x equals 3. So I'm going to put a 3 in, and I see that 3 times 5 does equal 15. So my answer of x equals 3, I know that's correct. For question number 11, we want to know 2 times what gives me 8. So I want to know what number could I put in here, multiply by 2, and give me 8. So the opposite of multiplying by 2 would be dividing by 2. So I'm going to divide both sides by 2. 2 divided by 2 is 1, and 1 times x is x. And 8 divided by 2 is 4. So I think that my answer is 4, and 2 times 4 does equal 8. So I see that x equals 4 is my final correct answer. Now, a lot of these are x's, and I could have used any other variable, but the variable you'll see the most is x. So if I want to know here what x divided by 4 equals, so I want to know what number divided by 4 equals 24. So the opposite of dividing by 4 would be to multiply by 4, which cancels out and leaves x alone on the left side. And 24 times 4, 4 times 4 is 16, carry the 1, 4 times 2 is 8, plus the 1 we carried is 9. So we see that x equals 96. A lot of you will look at that and be like, oh, 4 and 6 make 24, but 4 times 6 gives me 24. But I don't want to do 6 times 4. I want to do something divided by 4 to give me 24. So something divided by 4 gives me 24. I'm going to put a 96 in there, and 4 goes into 9 2 times with 1 left over. 4 goes into 16 4 times, and we see that 96 divided by 4 does equal 24. So x equals 96 is our correct answer. So we want to plug that back in because a lot of people think, oh, 4 times 6 is 24, but I don't want multiplication. I want to know what number divided by 4 gives me 24. In number 13, I want to know what number divided by 15 gives me 5. And a lot of you will look at that, oh, 5 times 3 is 15, but I don't want to know what number times 5 is equal to 15. So the opposite of dividing by 5 is going to be to multiply by 5. And 5 times 15 ends up giving me 75. So 15 goes into 75 5 times. So we know that 75 is our correct answer for x. Now for these division problems, it looks a little tougher, but we want to know what number divided by 15 is 5, not what number times 5 would give me 15. So in number 14, we want to know what number minus 4 gives me 9. So the opposite of subtracting 4, the inverse operation would be adding 4. We're going to do that to both sides, and 4 minus 4 is 0, so x plus 0 is x on the left, and 9 plus 4 is 13. And we're going to try that 13, and 13 minus 4 does equal 9, so we know that x equals 13 is our final answer. So we have x equals 13. For question number 15, we want to know 4 times what number gives me an answer of 20. So for x, we know that that means multiplication. So we want to know what number we could put in there, multiply by 4, and get 20. So we're going to divide both sides by 4, and 4 divided by 4 is 1, 1 times x is x, and 20 divided by 4 is 5. So I think my answer is going to be 5, but I want to double check that by putting my number in there. And 4 times 5 does equal 20, so we know that x equals 5. Make sure you go back and try a few of these on your own. So copy a few problems on a separate piece of paper, try them on your own, and then check your answer with the answers and the work from Miss Szymanski's notes.